This video is going to show how to install the SLP Indexer. This is the last major piece of infrastructure required to build the cash stack and talk at a low level to the Bitcoin Cash blockchain. In the previous videos, I showed how to install a full node, which is the gateway to the Bitcoin Cash blockchain. And then I showed how to install the Fulcrum Indexer, which tracks address balances and UTXOs. This second indexer tracks SLP token transactions on the blockchain. So if you aren't doing anything with tokens, then you don't need this. But if you are doing anything with tokens, you're definitely going to need this indexer. So as in previous videos, you'll want to start by going to fullstack.cash/cache-strap and downloading the pre-synced indexer database. Here's the IPFS hash. Here's a link to the Docker container we're going to be using. It's about 2.6 gigabytes. And as before, if you go to, I covered how to download them from IPFS in this part 1 video of installing a Bitcoin Cash full node, and you can get to that by going to psfoundation.cash/video, scroll down to the DevOps and infrastructure section, and then scroll to the right until you see this part 1 video, and that has more detailed instructions on how to download these files from IPFS. I am currently logged into the server that I've been covering, and I have the pre-synced database that I downloaded, and I unzipped it into this home folder. It might be a little different for you, but the file should be there, should roughly be there. If I go docker ps, I can see that I've got 3 containers running. One is the full node, the other 2 are the Fulcrum Indexer. This is going to set up a 4th Docker container, which is the SLP Indexer. So if you click on this link, it'll take you to the repository for the PSF SLP Indexer. Or you can manually navigate there by going to github.com, navigate to the Permissionless Software Foundation GitHub group, and the repository is PSF-SLP-Indexer. Now this is currently alpha release software, so I may update this video, but for now we're just going to follow the best instructions that are available right now. So first step is to clone the repository. So I'll git clone and then paste that URL in. And we're going to go into that directory and we're going to run the Docker container. So we're going to go into the production folder and Docker. And here are the different settings that you can use. Let's check out the Docker compose file. In particular of interest are these volume mounts. This is where the data will live. Just going to go up a directory and create a data folder, and that's where all the data is going to live. It's going to create a Mongo database directory or container, and then the SLP indexer. So yeah, it'll create a data directory right there. So I think we can just use the defaults for now. Let's go ahead and go docker compose build. And then I like to do this --no cache. This will ensure that it downloads a fresh copy of the GitHub repository when it's building the container. It won't use a pre-cached version, which can lead to problems. So whenever you rebuild this Docker container, I strongly recommend using this no cache option. So I'll let that run and build the container. Alright, so the Docker container is built. Let's take a peek at this start production file real quick. That got copied into the Docker container. This has all the different settings to configure the indexer. So debug level 1, and here's the connection string for the Mongo database. It's going to run on port 5010. This is telling it how to connect to an external Go IPFS node, which will launch when the Docker container launches. And here's the RPC settings to tell it how to connect to the full node. That's the only dependency that this software has, is a direct connection to a full node and then a direct connection to an IPFS node. This delete backup will delete the backups as it creates new ones. It saves hard drive space. And then there is another setting I'll talk about in a minute. So let's go ahead and fire this up. Now we're not pointing at the pre-sync database right now, so when this comes up, it's going to be syncing, trying to sync from SLP token genesis, which is the first block that contains the first SLP transaction. Okay, the Docker container came up. So let's take a look at that. SLP Indexer. Cool. I'll go ahead and stop it here. So it looks like it's syncing. It's going through and it's syncing. I just scroll up to the top. The first few blocks it goes through pretty quickly because it's they're mostly empty. Here we go. So it opened the LevelDB database and found the first block with the first SLP transaction in block 543376. So yeah, so it's indexing, it's off to the races. I'm going to go ahead and bring this down. So that's how you would index from SLP token genesis if you didn't have access to the pre-synced databases on the cache strap page. Now, one thing that I want to point out is that if you go to the Docker or to the repository, here in the config directory, and then env, and then common are this has all the major configuration settings, and most of them are overwritten by environment variables. And the one I want to point out here at the bottom is the blacklist, which is on by default, and by default it blacklists FlexUSD. FlexUSD is a stable coin, and they do a lot of airdrops. And so if your application specifically needs to use FlexUSD, you'll want to pass this disable blacklist into the startup file. So this start production file, you would edit it and go export disable blacklist equals 1. And then you would rebuild, you'd save that. I'm not going to save it, but you would save it, and then you would go docker compose build no cache. That would rebuild the Docker container with that environment setting. It'll then include FlexUSD in the indexing, which will make your database about 4 times bigger, and it'll take about 4 times longer to index. So there's really good performance reasons to ignore FlexUSD unless your application specifically needs it. That's why by default that one coin is blacklisted just for performance reasons. So that's how you do that. Let me just make sure, yeah, the Docker container is down. So if we go up a directory, we can see that there's this data directory that exists that was created, and that's where the LevelDBs exist. So if I go into LevelDB current, so this data LevelDB current directory contains the current indexer databases. So all these LevelDB databases. So what I'm going to do is go back up to where I have this pre-sync database unpacked, and if I just follow the directory structure, it'll take me to a current directory with this snapshot of this previously synced database. So I'm going to print this current working directory and copy that, and then I will go back to that data directory. Not there. There we go. Go back into the repository, the production directory, go back into this data directory, the level DB, and the current. And I have to use sudo here because they were created by the Docker container, so they had root permissions. I'm going to remove all these subdirectories down in here. Okay, they're all gone. And then I'm going to copy recursively all the files that were in that backup directory to this current directory. Oh, and I need sudo. Okay, so what I just did basically is I replaced the default level DB files that were created with the pre-synced versions that I downloaded from the cache strap page. So now when I bring the container back up, it'll just pick up where that snapshot left off. There we go. So let's look at our containers. Let's check out this SLP indexer. So we scroll up here. Okay, well, it looks like it's just going to town real quick here. Another trick is, I don't know if this head command works. Yeah, it doesn't. So if I go logs, I just want to look at the top, like 100 lines or so. So I'm going to pipe to head, and I'm going to say 100 lines. There we go. Now we can see the beginning of this. So it connected to the Mongo database. Current chain is 723. Indexer is currently at a height of 723.199. So there we go. That's off and running. And if it runs into trouble, it should automatically pick itself up. Let's actually check that. The Docker compose file. Yeah, oh, no, there's this restart always is commented out. So I want to make sure that that is uncommented so that if the indexer runs into trouble, it'll automatically restart itself. And I'll bring it down, and then I'll bring it back up. Okay. So now if the Docker container runs into issues, it should automatically pick itself up. You can always check on its status by going logs tail20 f SLP indexer. So that'll bring up the last 20 lines, but follow it so that you can watch the indexer in real time. So if we go to fullstack.cache, we can see that now we've got the full node, the Fulcrum indexer, and the SLP indexer, which completes like the basic low-level infrastructure required for the cache stack. In the next video, I'll show how to set up the BCH API REST API, which will provide a single common REST API, and it'll wrap these three pieces of infrastructure that we've set up, so that your software just needs to talk to one API, and then it can reach all this infrastructure.